Hey everybody, and welcome back. This is the first lesson in Unit 5. Unit 5 is radical functions, so we're going to be looking at things like square root functions, cube root functions, and higher root functions as well. Let's dive into today's lesson. So we're going to be talking about inverse functions of quadratic and cubic functions, so making sure that we go through that four-step process again for writing inverse functions. We saw that in the last unit. We're going to see it again in this one. And then we're going to also verify algebraically whether functions are inverses of each other or not using something called composition. Your essential questions for today: what type of function is an inverse to a quadratic? You may know this one already, just kind of based on your knowledge of inverse functions, but if you don't, that is going to be one of your goals for today. And then if a function is an inverse of another one, and we do this composition thing, what should the result be if the functions are inverses of one another? All right, in our last lesson, it was the end of Unit 4. We were doing models of rational functions, so we had a lot of word problems, and we had to model out what a rational function would look like to show the situation, and then we also had to go and solve them in some cases. Okay, so for inverse functions, you should be familiar with that four-step process. You've seen it before. This is nothing new. If you don't know that off by heart already, I would probably commit to memorizing that. It's one of the few things in this course that I would say yeah, you should probably memorize that one. Or just have really great notes and have them available for you. All right, on the other side then, we've got this weird f with f inverse of x inside of it. This is called a composition of a function. It's a function inside of a function. So why we would do that is if we were presented with something like, here's f of x, and here is g of x. Now there's like an actual function after these. I'm just putting question marks. I'm like, I don't want to make up one. So f of x is this, g of x is this. Are they inverse functions of each other? That would be the question. And the way we answer that is we say, okay, let me compose these functions. So I take what g of x is, and I substitute it in where x is in my original function. So say if this was 3x plus 2, I would replace the x value in this one. Say this one is, these are not going to be inverses, I'm just making this up, but minus 4x plus 5. So instead of x, I would replace it with minus 4x plus 5. So this would be 3 times minus 4x plus 5 plus 2. So I'm substituting in for the x value in one function. We're going to do this over and over again later, so I'm going to come back to that. But this is the idea of composition functions, that you put the inverse function in the place of x in the original function, or vice versa. And then you notice that the answer should be x. So x is what we call the identity value in functions. So we know from adding, if you take a number and add something to it and get the same number, that is your identity value. For addition subtraction, it is 0. If it's multiplied by something and you get the same answer back, the identity value is 1. For functions, if you compose a function by the identity value, which is x, you get back out the original function again. So x is the identity value for functions. So when we do composition of functions, we are going to try and get x. Because if you think about the identity for addition, the inverse of 3, that would result in 0, so in the identity would be minus 3. For half times blank, that would result in the identity value of 1, that's 2, so those are the inverses of each other. And then for f of x composed on f inverse, sorry about that, composed on f inverse of x, our answer should be x. So composition is, you might see it written as an open circle as well, so it's f of x after this. All right, let's get into it. Inverse of quadratics. So we're going to be applying that four-step process to a quadratic function. So four-step process, just once again, in case you don't have it written down, f of x becomes y. We want to isolate x. We want to switch x and y. And then we want to take y and convert it back into function form. So you can leave it in function form. It's just a little bit more tricky to track that the whole way through. It's easier to track a y as opposed to an f of x. Okay, so putting it through our 4 steps, y is equal to 0.5x squared. And you can leave it as 0.5, or you could write this as a half x squared if that makes more sense to you. Doesn't matter to me. So then we need to get x on its own, so we do y over 0.5 is equal to x squared, or in this case it would be 2y is equal to x squared. They're the exact same things. Y divided by a half is still going to be 2y. Now to get x on its own, you're undoing x squared, so that means we are square rooting both sides. Those are the inverse functions. So we would get the square root of y over 0.5. Now technically there's a plus or minus out here as well. And then on the other side it would be plus minus square root of 2y is x. Now in radical functions, we typically don't see that negative part being counted. So if you go to graph the inverse function, so a half x squared is something like this. The inverse function, remember, is that reflection over the line y equals x. So it looks something like this. So it looks like a parabola on its side, but it's actually only half a parabola on its side. The negative part, so the minus root 2y, would be the other half. So in a lot of cases, we are not asked to account for the negative part. We're usually only asked for the positive part, but just be aware that the negative is also there. Particularly for some real world problems, we may be interested in figuring that one out. So your answer anyway is this plus minus square root 2y, but we got to just convert it back to that last step. So switch x and y equals square root of 2x, and then f inverse of x is equal to root 2x. That's it. Now the last part is to verify that your answer is actually correct. So that was where I was talking about using that composition of functions. So then the question would be, if 0.5x squared is the inverse of root 2x, or vice versa, or are they the inverse of each other? So what we would do is we'd say, okay, f of f inverse of x is what? So f of x is 0.5, and then it's x all to be squared. G of x, or f inverse of x, so that's this one over here, is root 2x, so we substitute in the root 2x here. And then we want to know, if I were to simplify this down, so this is f of f inverse of x. If I were to simplify all this down, would I end up with an x? So is it equal to x question mark? All right, so the square root and the squared will cancel out because it's square root of 2x, so the whole thing is underneath. So I will end up with a half times 2x. And a half times 2 is 1, so I would end up with just 1x. So I'd be like, yep, verified. When I do the composition, I end up with just x. Now we know that quadratics can look a little bit more complicated than that. So if we've got one in the form of a times x minus h squared plus k, what does that look like when we do an inverse function? So let's try this one out. First step, substitute in y. Now if you're trying to get x on its own, what the general rule of thumb is that you are reversing PEMDAS. So PEMDAS, so that's our solving. If we're isolating a variable, we're doing it in reverse. So any addition, subtraction, get rid of it. So you're working back towards x. So the x minus 4 is inside a parenthesis. Parenthesis comes last in terms of my order of operations for isolating. So I've got to leave that till last. So the plus 3 is going to go first. So minus 3 on both sides. So y minus 3 equals 2 times x plus 4 squared. Next up, multiplication division. So I'm going to divide by 2 on both sides. So I've got y minus 3 all over 2 is equal to x plus 4 squared. Next up is exponents. So to get rid of the squared, I square root both sides. So I'm going to get square root of y minus 3 all over 2. So the whole thing is inside that square root is equal to x plus 4. And now the parentheses is gone because the square is gone. So now I can just subtract 4 from both sides. So I've got square root of y minus 3 all over 2. Square root bigger. Minus 4. So the minus 4 is not inside that square root, is equal to x. Okay, got x on its own. Now I can do the switch and replace it with f inverse. So f inverse of x is equal to square root x minus 3 all over 2 minus 4. And then the verification part. So if we are to double check that, so f inverse of x. Okay, this one's going to be a little bit bigger, but let's do it. So we've got, I'm going to have to erase some of this. I'm actually going to tuck my answer up here just so that I have it available to use, and then I'm going to erase that one down low. All right, so we've got f of f inverse of x. So f of x is 2. All right, now we've got our x part, so we're going to replace it with this. So 2 times square root of x minus 3 all over 2 minus 4, and then we've got another minus 4 squared plus 3 at the end. All right, so we have to evaluate this whole thing down. So we've got 2 times, now the whole thing is going to be squared, so let's see, we've got square root of x minus 3 all over 2 minus 8 times another one, square root x minus 3 all over 2 minus 8 plus 3. So a lot of work to do here. All right, so we've got the square roots times the square root. They'll cancel because the square root squared. So it's going to be 2 times x minus 3 all over 2. Then we've got minus 8 oh, hold on, made a mistake. So I just like those 4 should have canceled, and I'm just looking down here and I'm like, yep. So when I subtracted 3, I turned that minus over here into a plus. So this should have been a minus, which makes my final answer a plus. Okay, so that makes life much easier because I was like, this is not right. So that's a plus 4, which means they're just going to cancel. So those 8s can go. All right, much easier. I was like, man, I'm pushing you guys here. And I was like, I'm pushing myself here for a sec. All right, so that times itself plus 3. Perfect. So the squares cancel each other out, or square roots cancel each other out. And then we've got a plus 3 at the end. So then times 2 divided by 2, they're going to cancel. So we'll end up with x minus 3 plus 3. The 3's cancel, and we're left with x. So we're like, yes, this is verified. They are inverses of each other. So yeah, whew, sorry about that, guys. That was getting really confusing for a second. I was like, man, this is really pushing it. But no, all much simpler than I was making it out to be. So all good. Moving forward. Your turn. All right, your turn. Take a shot at these two, and then come back and see how you did. I'll go through it with you as well. Please make sure you are verifying the function you're using composition and showing that work as well. Get used to going through that algebraic stuff because I'm going to ask you for that. All right, so first one, y equals 2/5 x squared. To get rid of 2/5, we multiply by 5 over 2 on both sides. So the 5's cancel, the 2's cancel. So we get 5 over 2. times y equals x squared. To get x on its own, we do square root of both sides. So square root of 5 over 2y is equal to x. Switch x and y, and that's also our inverse function. So f inverse of x is going to be equal to square root of 5 over 2x. Now the composition part, so f of f inverse of x, is that going to be equal to x? That's the question. So we put it through 2/5. Now x, instead of x, we're going to be putting square root of 5 over 2x, all to be squared. Square root and square cancel. 2 and 2 cancels, 5 and 5 cancels, and we're left with x. So we're like, yes, done. Now for the other one, a little bit more work involved here, and I'm afraid of running out of space. So I'm going to try and keep it all in one spot. All right, so we got y equals minus 2, x minus 1 squared minus 9. Add 9 to both sides, and then divide by minus 2. So plus 9 divided by minus 2. That's going to be equal to x minus 1 squared. So I did 2 steps in one there, just kind of save space, but I added 9 to both sides and then divided by that negative 2. So I'm left with x minus 1 squared. To get rid of that, I'm going to have to do square root of both sides. So square root of y plus 9 over negative 2 is equal to x minus 1. And then I add 1 to both sides. So I get, that'll be x on its own, so that'll be, to finish it off, f inverse of x is going to be equal to the square root of x plus 9 over minus 2, and then plus 1. So added 1 to both sides. And then I just did my switcheroo at the end. So I did all those last steps. So this is what your answer should look like. If it doesn't look like that, go through the steps again or ask me questions, and I will be happy to answer those for you. The inverse part, so we have to sub in the inverse function for x. So it's going to be minus 2. Now our x part is square root of x plus 9 all over minus 2, and then we've got plus 1, and then inside the parentheses still a minus 1 squared minus 9. So the plus 1 minus 1 cancels. The square and the square root will cancel, so we get minus 2 times x plus 9 all over negative 2 minus 9. The minus 2's cancel. X plus 9 minus 9's cancel, so we're left with just x verified. So when you do this in a test or quiz, if I'm asking you to show work, I'm going to need you to show me more than just, like you could say this, but I would need at least a step in between to show me, like, okay, that you actually substituted them in and you cancel down to get x on its own. All right, inverse cubics, there's really not much different going on here. It's the same thing, except we're going to have cube roots instead of square roots. So y is equal to 8x cubed. To get x on its own, we divide by 8 on both sides, so it'll be y over 8 is equal to x cubed. So the opposite of cubing something is to take the cube roots. There's a little 3 inside of here. So cube root of x cubed, so cube root and the cube cancel, and we get the cube root of y over 8. Now, one thing to note, when you get a cube root of y over 8, this is the equivalent, so you can always split a fraction like this, cube root of y over cube root of 8, like that. You can do that with fractions. You can just split the numerator and denominator and just say they're both still cube root. But the cube root of 8 is 2, so 2 cubed is 8, so the cube root of 8 is 2. That's the opposite of it. So just, if you don't know that, check it on your calculator. You can always do cube root of any number and see, what is the answer, and if it's a whole number, then simplify it. So this would actually end up being the cube root of y all over 2 is our simplified version. And we're going to switch x and y. So y is equal to cube root of x all over 2. And that will be my inverse function as well. So f inverse of x is cube root of x all over 2. Now to do the composition, so we have 8 times, my 3 kind of look like a 3 times, so that's the hard part, is like keeping it as cube root, so it needs to be a pretty small 3. So we got cube root of x all over 2 cubed. So now when you cube a fraction, you end up cubing the top and the bottom, so they both get their own cube. So this means that we end up with 8 times cube root of x to be cubed. They cancel, so we end up with x, and then 2 cubed is 8, and then the 8's cancel, we're left with x. So verified. All right, let's do a longer cubic, so that ax minus h plus k scenario. So we've got y equals minus x plus 4 cubed minus 1. Add 1 to both sides. And then let's divide by -1. That'll cause that negative to cancel out. So over -1. You could also multiply by -1, but either one works here. So we've got y plus 1 divided by -1, so that would simplify to be minus y minus 1 is equal to x plus 4 cubed. So then we do our cube root of both sides to get that to cancel. So we get cube root of minus y minus 1 is equal to x plus 4. We're going to subtract 4 from both sides. So it's going to be cube root of minus y minus 1 and then minus 4. Is equal to x. So that means f inverse of x is cube root of minus x minus 1 minus 4. So the minus 4 is not included in that cube root part. So then composition, substituting in for the x, we're going to have minus cube root of minus x minus 1 minus 4, and then plus 4, so that's the plus 4 over here. Close it to be cubed minus 1. So this is the minus 1 in the cube part. That's where those are coming from. So I'm literally just taking this and substituting it in the place of x in that original function. All right, so the minus 4 and the plus 4 cancel. The cube and the cube root will cancel. So I get minus x minus 1 minus 1. Distribute the negative. So we get x plus 1 minus 1, which they cancel down, and you're left with just x. So verified. All right, your turn. 2 examples. Pause the video, try and write the inverse functions, verify them as well, and then come back and see how you did. Okay, so first one, x cubed minus 9. We got y equals x cubed minus 9. Add 9 to both sides. Y plus 9 is equal to x cubed. Cube root both sides. Cube root of y plus 9 equals x. Switch x and y and do your inverse function. So we get cube root of x plus 9. Then verify it. So we're going to substitute in instead of x. So we got cube root of x plus 9, all to be cubed, minus 9. So the cube root and the cube will cancel. So we get x plus 9 minus 9. 9's cancel. We're left with x, verified. All right, so for the last one, we're going to replace this with y, and then we're going to subtract 12 and then divide by 8. So I'm going to try and do a couple steps in one go. So we got y minus 12 all over 8. is equal to x plus 1 cubed. We're going to cube root the whole thing. Now, cube root of 8 is 2, so this is going to be all over 2. It's equal to x plus 1, so we're going to subtract 1 from both sides. So that means my inverse function is going to be the cube root of x minus 12 all over 2 minus 1. And then to verify it, we got 8 times cube root of x minus 12 all over 2 minus 1 plus 1 plus 12. So the ones cancel. That's all to be cubed. So cube both of these, the cube root will cancel, and this will become a 2 cubed. So we get 8 times x minus 12 all over 8 plus 12. 8's cancel, so we get x minus 12 plus 12. The 12's cancel, we're left with x verified. Okay, so our essential questions. What type of function is the inverse to a quadratic function? That would be a square root function. Remember, radical functions are any ones that contain square roots, cube roots, fourth roots, that sort of thing. So if there's a root in there, it's a radical function. If a function is an inverse to one another, what should the result be if they are composed of one another? So if you do a composition of a function and its inverse, the answer should be x. If it's not x, that means they are not the inverse of each other. One thing we didn't mention, but we should have talked about, which we did before, was that if you reflect over line y equals x, a function and its inverse will be symmetrical over that line y equals x. So keep an eye out for that. If you want to check your answer visually with Desmos, you can do. If I'm asking you to prove that they are inverses using composition, Desmos, or saying they look like a reflection of one another will not count. You will have to show the algebraic version, so please make sure you're comfortable doing that. All right, so after today, you're going to complete the week's work. You've got inverse of quadratic and cubic functions folder. Finish that off. There's some textbook work in there, and then you have a math task to complete as well. All right, I'll see you soon.